Hello, this is Pawan here. This is the project I've done in the machine learning CS 767 course. It's called Skyride. It's basically predicting the prices of any native using astrology and machine learning. So let's look at this project. So Skyride app is an attempt to predict prices of various natives using astrology. So yeah, the natives can be anything which has a date of birth, place, and time. So in this particular course, I have taken the native of gold because gold is something which has something to measure against. So they are gold prices. So the performance will be measured against the gold prices. So all the astrology rules will be fed to a machine learning algorithm in the form of data to learn from the past and predict the future trend. So following planetary data will be fed. So the planetary angles, planetary motion, and planetary location. So planetary angles are angle between any two planets. So basically, it can be from minus 360 degrees to plus 360 degrees. So I've taken only in one direction. And the planetary motion is 0 and 1. So it can be 0 or 1. So it can be a regular direction is 0 and retrograde is 1. And planetary location is in which constellation the planet is. Constellation is nothing but 13.3 degrees is one constellation. So there are like 27 constellations in the 360-degree complete circle. So that is one data. So at any given time, what planets are in what constellation, which affects the gold prices pretty, in a pretty decent way. So those has been taken. So choosing the right machine. So there are several machine learning algorithms. So based on this particular project, so for Skyride app, neural net and expert systems are suitable as it has reliable data and tried and tested rules. So currently only neural net will be used. Expert system will be added later to enhance accuracy. So for the Skyride app, there are pretty solid, reliable data. Basically, the planetary data, which is pretty accurate. I would say 100% accurate. And then the prices data. The prices are up or down and by how much. So that all the complete data is pretty accurate. So that makes neural net a pretty suitable candidate for predicting prices. And the other is astrology has a bunch of rules. So expert systems is also pretty good for predicting prices for like gold in this case, because there are a lot of rules which can be used and prices can be predicted. So in this course, only neural net is being used, and probably I might be also using expert systems going down the line, because right now the accuracy which I'm getting is pretty low, and they might really help me out. So choosing the right machine parts. So to build the neural net, there are several things that goes into it. These are only a few of them, but I know there's a lot more than this. But this is what I have tried, different permutations and combinations, and I have got the accuracy of around 50% right now. So following neural net configuration will be used for training, evaluating, and predicting prices. So the layers. So neural net has by default input and output layer. Besides, I have a few hidden layers. So input layer will be 26 neurons, as there are 26 features. So one neuron per feature. And output layer is only one. So there's just one target. It's like prices is up or prices down, 0 or 1. So there's one target / label. And hidden layers, I have tried with different hidden layers like 2, 3, 4, 5. So 5 probably gave me better accuracy, so I kept 5. And I've tried with different neurons, like from 32 to 256. So the functions, for the activation function, I have tried several different functions: tan, hedge, sigmoid, ReLU, and leaky ReLU. The best results I got is using tan hedge. Sigmoid was giving very narrow results with around 0.5, and ReLU was giving very divergent results, ReLU and leaky ReLU. So since I read a lot of really good reviews about leaky ReLU online, I tried leaky ReLU for the hidden layers, and one time tan hedge and one time sigmoid for the output layer. But still, after a certain time, there was no divergence in the cost, and the cost was pretty flat. So I could not use that combination either. So the best one that it worked for me was tan hedge for all the layers, hidden and output. And for the cost function, mean square error, root mean square error, they all were pretty much the same. Optimizers, I use the gradient descent optimizer initially, and then later on I use based on the online research Adam optimizer. And Adam optimizer was pretty fast, and actually it gives slightly better results. For iterations and batch sizes, I tried all different permutations and combinations. I went up to a max of 20k epochs and batch sizes, varying batch sizes, and learning rate from 0.00001 to 0.001. The maximum training I did was for up to an hour, a little over an hour, and pretty much still the results were pretty much the same, around 50%. So that's the best I got. Data, so the data for planets what got from a public API, and that data was like formatted, massaged, and loaded into a CSV file, and then it was, since the data range was minus 360 to plus 360, it has to be fit and transformed in order to feed into the network. There was around 50 years of data in it from 1969. This is pretty much when the gold is considered to be born. It was listed on the Chicago Mercantile Exchange. So around 1969 till today, 2018, up to December, which is the 3 months in the future. So the data for 50 years, and it has around 12,500 rows and 27 columns. So 12,500 rows basically is only for the working days, not on the holidays. And then 27 columns has 26 features, input features, and one label, which is output feature. So I guess we can look at the TensorBoard. So I was playing around with TensorBoard, and we can look at real quick. So this is a Jupyter I used. So this was, it helped a little bit, but still I need to explore more TensorBoard to understand. So this is, these are all the weights, and then this is actually, I think, the mean model. So if you look at here, it's the cost function, mean squared, and then this is the output layer right here. This is the output layer, and then these are all the hidden layers here. Skyride here, hidden layer 1, 2, 3, 4, 5. So SR I have put for the skyride, and this is the input layer. So input layer, hidden layers, output layer, and these are all the permutation and all the calculations being done. And this is the Adam optimizer which I have used. This, I think it has a lot of information in here. So if you can visualize to see, since it's a complete black box, it shows that weights and biases are getting updated and all the different information. So I did not explore a lot in this, but it has a lot of information. So that's the TensorBoard, which helped in visualizing to see what's going on inside the neural network. And then Jupyter also was very helpful in analyzing the data to see what kind of data is there. Like this one has got what type of data is being fed, and there's some plotting which can be done, stuff like that. So Jupyter also was very helpful in understanding more details about machine learning. It's a pretty handy tool. Coming back to the actual code, I can look at the data real quick once. So the initial data is this one, which is the data which I got from the API, and I did some formatting in Java, and then I put that into a CSV file here. So it's from 1969. It starts from all the way from 1969. It goes, I think, all the way till 2018 here, 2018 December. So so this data was put into a couple of files here. One is this file. So there's no date in this. It's just the angles, planetary angles. So these are the planetary angles from till O, and then from here it's these are the retrograde positions. So 0 is regular position direction, and 1 is a retrograde direction. And these are the constellations from 0 to 27. And the last one is a label, is the gold price was up or down on that particular day. So, and I think I have, this is the actually the training and the test data, and there's a future data which is, I think, separate for October, November, and December for 3 months. So this is what actually the predictions are needed for. So there's no label here. It's just the future data. So looking at the actual code here, so I tried a few different ways. So I tried the regular way, the one that we learned in the class. So it's pretty straightforward, same stuff. So first the data is being read from the CSV file, and then is being split here. Is being split, so all the libraries are here. I'm using the sklearn model selection split, and then scaling and transforming and fitting the data for feeding to the neural network. And then for going further down, all these are the different variables, different hidden layers, and then how many nodes, neurons are there, the placeholders, and these are the weights and biases, which are mostly random. And these are the different functions I have tried. I have tried the sigmoid, I have tried the leaky ReLU, then I've tried the TANH, which is what I'm run right now. TANH was the one which gave slightly better results. And then this is the cost function. So the same squared mean square. And then the learning rate, I just kept it 0.01, but I tried all the way to like 0.0001. Optimizers, I tried the gradient descent optimizer, the proximal and diagonal optimizer, and then the Adam optimizer. So Adam gave better results. And that's pretty much it. So just running the neural network session here, epochs, batch size, and display size. So this was running into different batches. So initializing, and then this is the one that was so number of batches. So this is a training data which is being used initially for training, and this was writing to the for the tensor board that we just looked at the graph. And then so it's feeding the batches, so it's splitting into batches and then going over the batches one by one here, and then getting the average cost, which we'll see in the logs. It logs the average cost here, and then it calculates the accuracy based on the predictions. And then once for the future data, so this is the future data which is like for 3 months. I have run the same trained session on this, and then I have fed the input data to it, and it has given the final outcome based on the data. So it had made the predictions here, basically the whatever the output is from that. So let me run this real quick, and then we can look at. It should not take a lot of time, maybe like a couple of minutes, not a lot, because I have kept their settings pretty low. So I'm logging the results here. So this is just the data which I'm logging here, the input data. So this is of shape. The total shape for X is this 12501. This is the total file, 26 features and one feature, one label. And then you can see the data, the accuracy is going up from 0.695 to 251. So let me just pause this a little bit. My computer is kind of going blank up and down. I'll just pause it for a bit, and then once it's over, I will start again. So it looks like it's coming to an end now. So this is what I was talking about. The accuracy is around 50%, and this is the prediction for the data, which has been, the future data. So it's basically from -1 to +1. So same thing from the Skyrad estimator also. I think I have put down the results into a different file here. So what I did was I took all those output from -1 to +1 for September, October, November, and December, which is for the next 3 months. And then looks for the past couple of weeks, the predictions had been around 60% accurate. So I don't know if this is how I would test it out, but like a manual testing wise, so till this like October 19th, this has been around 60% accurate. and then I have put down the predictions for the next couple of months, like October, November. So from this, it looks like October or maybe almost till November first week, it's mostly green, and then from November second week, it's going to be more red all the way till Thanksgiving or maybe till December. So that's how I have did some manual check also on this to see how the accuracy is actually meaning something, but it looks like it's around 60%, maybe 50-60% based on the future data, which is like just for like a month I've checked. So this is the Skyride using the estimator API. So I tried a few of them. So this is the second one, estimator. So this is actually pretty straightforward. It's all built in. I did not have to do a lot in this because this is what I got from the awesome online resource, all the information. So the same thing, reading the data from the CSV files and then splitting the data and then scaling it to fit to a scale. And then the most important thing here was using a classifier. So I did a linear classifier, I did a linear regressor, and I tried a DNN classifier, which is a deep network classifier. So right now I have this one enabled. So I have tried different permutation and combinations to see if I can improve the accuracy. The reason I use the linear classifier is because my output is 0 or 1. What I'm expecting is a 0 or a 1 based on the input data. So I felt it might work, and the classifier also might work. So it also gave me around 50% accuracy, and this is pretty much the same results. So I did not see a lot of difference, to be honest. So basically what this is doing is this has different input functions here, and all these input functions have got their own like X train data, X test data with the Y test data, and this is the future, only the X test data. There is no Y test data in this. So so here I'm just taking the linear classifier instance, and I'm just training the input data first for the X train data, and then I'm making the predictions for the test data, which is like predict input here, only the test. There is no Y being fed into this, so it's supposed to give me the predictions, the Ys, and then I'm going to check these predictions against the Y test data to see how accurate they are. So I'm just feeding the X test but not giving the Y test. Y test I'm checking with the classification report to see what the report looks like. So let me run this quick. It's like 1 second. It shouldn't take a lot of time to run. I've done very low settings on this. Oh, I think it's running the old one. Sorry about that. Let me run from here. Start estimator. Run as Python. Okay. So this should be like a second, 2 seconds maybe. Yeah, there you go. So this gave around 52. This is the best I have got so far, around 48, 50, 52. These are the precisions I have got from this. So and this is it's a set of 251 test data. So that's pretty much it, I would say. So looking at overall details of the project and the way things came up, looks like the accuracy still needs to be improved a lot, and there's a lot for me to learn in this. So I guess I'll be spending some more time and trying to improve the neural network output, possibly getting into the 60-70% range, and then also put the expert systems in it and try to see how both can talk to each other and get the best of both the systems and try to make a more accurate system. But so far I don't think things are looking that bad. It's certainly the right direction. It's just going to take some more time. So that's pretty much it. Thanks for your time.